Most security advice starts with keeping threats out. At some point, that stopped being enough. Because after the last few supply chain attacks, the question that stuck with me wasn't how do I prevent this? It was something else. When something malicious runs, and eventually something will, how much can it actually reach? Hey, I'm Natalia. I've been in engineering for around 20 years, and I care about building systems that are not just secure on paper, but resilient in reality. If you saw my last video, you know why this matters. Trusted tools, real compromises, malicious code running inside tools people already trusted. And everything within reach was already being used before anyone noticed. This video is about what I did next. I rebuilt my development environment around one idea: nothing worth taking. Not nothing can go wrong, just nothing worth taking. The instinct after seeing those attacks is to try to prevent them. Better scanning, pinned versions, audited dependencies. All of that matters. None of it is enough on its own. Because the attacks that concerned me weren't the ones I could see coming. They were hiding inside tools I already trusted. Tools I was running specifically to protect myself. So I stopped asking, how do I prevent this? And started asking something else. How little can it actually reach? That's blast radius containment. Not perfect security, just less to lose. And it starts with a very simple mental model. That sounds abstract, but it isn't. Your machine has two layers. The host is minimal. It runs Docker. It holds almost nothing worth stealing. Everything else happens in the container. Your editor, your tools, your dependencies. That's where code runs. That's where something malicious would run too. If something goes wrong inside the container, the host is untouched. And the container itself, you don't fix it, you just throw it away. Not patched, not scanned and hope for the best, deleted and recreated from the pre-contamination image in under a minute. Containers are ephemeral by design. That's not a limitation, it's an escape hatch. Whatever a compromised container picked up during a session disappears with it. That's the foundation. Everything else builds on it. That idea turns into 4 layers. The dev container. This is a workshop. You open a project and everything runs inside the container. Your editor, your tools, your terminal. No direct access to your machine. What's not there? No SSH keys, no cloud credentials, no tokens. If something runs here, it only sees what you gave it. Isolation protects your host, but it doesn't stop something from calling home. Without that, they don't do much. No connection, no exfiltration. The container runs behind an allow list firewall. Default deny. The only domains permitted are the ones your project actually needs. If something tries to phone home to an unknown domain, the connection is refused. And it's locked. During development, it catches things you wouldn't expect. That's how you know it's working. If someone gets your SSH keys, they don't just get your machine, they get your infrastructure. That's why they go for them first. In this setup, there are no private key files. Not in the container, not on the host. Nothing sitting in the .ssh waiting to be taken. .env files are convenient. They are also a list of everything an attacker hopes to find. Database access, API keys, cloud credentials. In this setup, those don't exist as files. They're injected at runtime and disappear with the process. If the container is compromised, what the attacker gets is a running process environment, not a file they can copy and carry out. That's a meaningful difference. A process environment disappears when the process does. A credential file stays until someone finds it. Individually, these are small things. Together, they change what an attacker can actually do. But they don't just affect attackers. They affect you too. The firewall will block things you didn't expect. You'll debug things that used to just work. And when your setup isn't aligned, authentication breaks in annoying ways. You fix it, you adjust, you keep going. I'm not going to tell you this takes a weekend. It took took me longer than that. I've been running this setup for a few weeks and I'm still finding things that need fixing. But here's what I can tell you. I feel less anxious about my data than I ever have. Not because I think I'm untouchable. I know that's not how this works. But because I know I'm doing everything I can to not be the easiest target in the room. And that shift from hoping nothing goes wrong to having actually thought through what happens when it does, that's worth a lot of friction. Because this is what that friction buys. An attacker who gets malicious code running inside my container gets a container. No unrestricted outbound network access, no SSH keys, no cloud credentials, no .env files. Not zero risk, but a dramatically smaller blast radius than where I started. 4 layers, 1 mental model. None of this is magic, none of it is bulletproof. A sophisticated, patient attacker with enough access can work around almost anything. But these 3 attacks, Glassworm, Axios, Drivey, they were going for the easy wins. The keys sitting in their .ssh, the credentials in .env, the unfiltered outbound connection back to a waiting server. This setup takes away the obvious targets and gets you a lot closer to nothing worth taking. If any of this resonates, the SSH key setup, the firewall, the secret handling, I'll be going deeper on each of these layers. Subscribe so you don't miss it. See you in the next one!